Hello dear students, I welcome you all. Today our topic is about the material that has left an indelible mark on the world we live in. A material that has redefined architecture, sparked innovation and shaped our built environment. Yes, we are talking about plywood. Join me in this lecture to explore a material that despite its humble origins has become an indispensable cornerstone of modern construction. From towering skyscrapers to intricate art installations, plywood's adaptability and versatility have transcended boundaries, pushing the limits of what is possible in design and engineering. In this lecture, we'll be talking about its definition and history, raw materials used in its formation, plywood classification, grading and sizes, manufacturing process of plywood, properties of plywood, and lastly we'll talk about uses of plywood. Let us start with its definition. Plywood is an engineered wood sheet material made of 3 or more thin layers of wood bonded together with an adhesive. Each layer of wood or ply is usually oriented with its grain running at right angles to the adjacent layer in order to reduce the shrinkage and improve the strength of the finished piece. Most plywood is pressed into large, flat sheets used in building construction. Other plywood pieces may be formed into simple or compound curves for use in furniture, boats, and aircrafts. Let's now explore the historical narrative of plywood and its transformative journey through time. The use of thin layers of wood as a means of construction dates back approximately 1500 BC, when Egyptian craftsmen bonded thin pieces of dark ebony wood to the exterior of a cedar casket found in the tomb of King Tutankhamun. This technique was later used by Greeks and Romans to produce fine furniture and other decorative objects. In the 1600s, the art of decorating furniture with thin pieces of wood became known as veneering, and the pieces themselves became known as veneers. Until the late 1700s, the pieces of veneers were cut entirely by hand. In 1797, Englishman Sir Samuel Bentham applied for patents covering several machines to produce veneers. In his patent application, he described the concept of laminating several layers of veneer with glue to form a thicker piece, the first description of what we now call plywood. Despite this development, it took almost another 100 years before laminated veneers found any commercial uses outside of the furniture industry. In about 1890, laminated woods were first used to build doors. As the demand grew, several companies began producing sheets of multiple ply laminated wood, not only for doors but also for use in railroad cars, buses and airplanes. In 1928, the first standard size 4 feet by 8 feet plywood sheets were introduced in the United States for use as a general building material. In the following decades, improved adhesives and new methods of production allowed plywood to be used for a wide variety of applications. Today, plywood has replaced cut lumber for many construction purposes, and plywood manufacturing has become a multi-billion-dollar worldwide industry. Dear students, let's take a closer look at plywood's extensive array of types categorized by raw materials used in their production. Plywood may be made from hardwoods, softwoods, or combination of the two. Let us discuss about some plywood types. The different types of plywood are softwood plywood, hardwood plywood, tropical plywood, aircraft plywood, decorative plywood, flexible plywood, and marine plywood. Starting with softwood plywood. Softwood plywood, which is also known as spruce pine fir or SFP because it's made from spruce, pine and fir. Though it can be made from cedar and Douglas fir also. Softwood plywood is less dense and may not be as strong as hardwood plywood. However, it still offers good structural integrity and is often preferred for its lighter weight. Softwood plywood may have a more pronounced grain pattern and slightly rougher texture compared to hardwood plywood. It is commonly used in applications where appearance is of less concern or where a rustic look is desired. Let's now shift our focus to another type of plywood, hardwood plywood, which offers different properties compared to softwood plywood. Hardwood plywood is made from angiosperms. This type of plywood is identified by its firmness, hardness on surface, inflexibility and resistance quality. This can be used to bear heavy weight. Hardwood plywood is generally denser and stronger than softwood plywood due to the nature of hardwoods. Hardwood plywood is typically more expensive than softwood plywood due to higher cost of hardwoods and their slow growth rate. It's often chosen for high-end projects where quality and aesthetics are paramount. Moving on from hardwood plywoods, let's know about tropical plywood, which is known for its durability in tropical climates. Different types of timbers of tropical area are mixed to make this type of plywood. Though previously it was only collected from Asian region, now it is also collected from Africa and America. Now let's talk about aircraft plywood, which is designed to meet strict aviation standards and ensure safety in aircraft construction. Woods from mahogany, spruce, birch are used to make aircraft plywood. The African mahogany gives usable structural aircraft plywood. Among birch trees, European birch is good. This type is famous for its strength. Next up, let us talk about decorative plywood, which adds aesthetic appeal to various interior and exterior applications. Decorative plywood is also called overlaid plywood, usually made from wood of ash, oak, red oak, birch, maple, mahogany and rosewood. Shifting gears, let us move on to the flexible plywood, which offers versatility in bending and shaping for curved surfaces. As the name goes, flexible plywood is used for making flexible furniture or structures. The furniture of 18th century were mostly of curved structures. These are made from Baltic birch, which is a Betula species. Now, let us turn our attention to marine plywood, specifically engineered to withstand moisture and harsh marine environment. The type of plywood which can be used in moist, humid and wet environment for long period is called marine plywood. The layers of marine plywood bear two small core gaps to fill that doesn't permit the wood to fix water inside the gaps. It is also fungal resistant. Dear students, there are various types of adhesives that can be used to combine the layers of wood to create a sheet of plywood. The type used depends on the usage for the plywood. For example, a phenol formaldehyde resin will be used if the sheets are to be used for structures exterior. That is because the adhesive is very strong and will resist any damage caused by moisture, an important feature for any outdoor project. On the other hand, if the plywood is to be used For the interior of a structure, the adhesive used is usually either made from soybean protein or blood protein. However, many of the interior plywood sheets will now often use the same phenol formaldehyde resin that is used for exterior sheets. Finally, if the plywood is to be used for building furniture, the adhesive is usually made with the urea formaldehyde resin. As we continue our journey through the world of plywood, let us know about plywood classification, grading, and sizes. In general, there are two classifications of plywood, both of which have their own grading system. The two classes are construction or industrial and hardwood or decorative plywoods. Those plywoods that are included in the construction or industrial classification are used for their strength. They are rated depending on the grade of veneer that is used on their back and face, as well as their exposure capability. That exposure capability can be either exterior or interior and usually depends on the type of adhesive used. Veneer grades may be N, A, B, C or D. N grade has very few surface defects, while D grade may have numerous knots and splits. For example, plywood used for subflooring in a house is rated interior CD. This means it has C face with a D back and the glue is suitable for use in protected locations. The inner plies of all construction and industrial plywood are made from grade C or D veneer, no matter what the rating. The second classification of plywood, called hardwood or decorative, is used for its overall attractive appearance. The grading in this class is dependent upon the plywood's ability to resist moisture. The face of the plywood is almost always free from defects, at least by the naked eye, given that it is used for its decorative purposes. The gradings are Type 3, Type 2, Type 1 and Technical. They are graded in descending order of resistance to moisture as Technical, Exterior, followed by Type 1 Exterior, followed by Type 2 Interior and lastly Type 3 Interior. Their face veneers are virtually free of defects. Dear students, now let us talk about the sizes of plywood. Plywood sheets range in thickness from 0.06 inch to 3 inch. The most common thicknesses are in 0.25 inch to 0.75 inch range. Although the core, the cross bands and the face and back of a sheet of a plywood may be made of different thickness veneers, the thickness of each must be balanced around the center. For example, the face and back must be of equal thickness. Likewise, the top and bottom cross bands must be equal. The most common size for plywood sheets used in building construction is 4 feet wide by 8 feet long. Other common widths are 3 feet and 5 feet. Lengths vary from 8 feet to 12 feet with 1 feet increments. Now, let's dive into the fascinating manufacturing process of plywood. The trees used to make plywood are generally smaller in diameter than those used to make lumber. In most cases, they have been planted and grown in areas owned by the plywood company. These areas are carefully managed to maximize tree growth and minimize damage from insects or fire. The first step in formation of plywood is felling the trees. Selected trees in an area are marked as being ready to be cut down or felled. The felling may be done with gasoline-powered chainsaws or with large hydraulic shears mounted on the front of wheeled vehicles called fellers. The limbs are removed from the fallen trees with chainsaws. The trimmed tree trunks or logs are dragged to the loading area by wheeled vehicles called skidders. The logs are cut to length and are loaded on trucks for a trip to the plywood mill, where they are staked in long piles known as log decks. Now comes the step preparing the logs. As logs are needed, they are picked up from the log decks by rubber-tired loaders and placed on a chain conveyor that brings them to the debarking machine. This machine removes the bark either with sharp-toothed grinding wheels or with jets of high-pressure water while the log is slowly rotated about its long axis. The debarked logs are carried into the mill on a chain conveyor where a huge circular saw cuts them into sections about 8 feet 4 inch into 8 feet 6 inch. Dear students, let's now talk about another step, that is making the veneer. Before the veneer can be cut, the peeler blocks must be heated and soaked to soften the wood. The blocks may be steamed or immersed in hot water. This process takes 12 to 14 hours depending on the type of wood, the diameter of the block and other factors. The heated peeler blocks are then transported to the peeler lathe, where they are automatically aligned and fed into the lathe one at a time. As the lathe rotates the blocks rapidly about its long axis, a full-length knife blade peels a continuous sheet of veneer from a surface of spinning block at a rate of 300 to 800 feet per minute. The long sheet of veneer emerging from the peeler lathe may be processed immediately, or it may be stored in long multiple level trays or wound on rolls. In any case, the next process involves cutting the veneer into usable widths. At the same time, optical scanners look for sections with unacceptable defects, and these are clipped out. The sections of the veneer are then sorted and staked according to grade. The sorted sections are fed into a dryer to reduce their moisture content and allow them to shrink before they are glued together. Let's now learn about forming the plywood sheets. When appropriate sections of veneer are assembled for a particular run of plywood, the process of laying up and gluing the pieces together begins. This may be done manually or semi-automatically with machines. In the simplest case of 3-ply sheets, the back veneer is laid flat and run through a glue spreader which applies a layer of glue to the upper surface. The short sections of a core veneer are then laid crossways on the top of the glued back, and the whole sheet is run through the glue spreader a second time. Finally, the face veneer is laid on the top of the glued core and the sheet is staked with other sheet waiting to go into the press. The glued sheets are loaded into a multiple opening hot press. Presses can handle 20 to 40 sheets at a time, with each sheet loaded in a separate slot. When all the sheets are loaded, the press squeezes them together under a pressure of about 110 to 200 psi, while at the same time heating them to temperature of about 230 to 315 degrees Fahrenheit. The pressure assures good contact between the layers of veneer, and heat causes the glue to cure properly for maximum strength. After a period of 2 to 7 minutes, the press is opened and the sheets are unloaded. The finished sheets are stamped with a grade trademark that gives the buyer information about exposure rating, grade, mill number, and other factors. Sheets of the same grade trademark are strapped together in stacks and moved to the warehouse to await shipment. Dear students, now it is time for knowing the step quality control. Just as with lumber, there is no such thing as perfect piece of plywood. All pieces of plywood have a certain amount of defects. The number and the location of these defects determines the plywood grade. Standards for construction and industrial plywoods are defined by product standard, that is PS1, prepared by the National Bureau of Standards and the American Plywood Association. Standards for hardwood and decorative plywoods are prepared by the American National Standards Institute and the Hardwood Plywood Manufacturers Association. These standards not only establish the grading systems for plywood but also specify construction, performance, and application criteria. Dear students, we have reached a segment of presentation where I will discuss some plywood properties. The major properties of plywood that we need to know about are high strength and dimensional stability, high impact resistance, panel shear or braced panel shear, water and chemical resistance, flexibility or bendability, and fire resistance. First, let us talk about high strength and dimensional stability. Plywood is an extremely versatile material and can be used for a variety of applications, including flooring, wall panels, and roofs. It is also one of the most dimensionally stable wood products available, meaning it is less likely to warp or shrink over time. Let's shift our focus to another standout property, that is, it is high impact resistance. The high impact resistance property of plywood makes it a popular material for construction and manufacturing applications. This property allows the plywood to withstand high levels of stress without breaking. The strength and durability of plywood makes it a popular choice for applications that require a strong and durable product. Let's now turn our attention to its impressive strength in shear, making it ideal for use at shear walls or bracing in construction. Plywood panels are very strong in shear and often used as shear walls in construction. The panels are glued together with strong adhesive and the joints are reinforced with staples or nails. The panels are also often used as bracing in construction and are very effective in their application. Dear students, yet another property of plywood is water and chemical resistance. Plywood is generally considered to be a durable material, but its water and chemical resistance depends on the type of wood used, the adhesives used to bind the layers of wood together, and the finish applied to the surface. Some types of plywoods are more resistant to water and chemicals than others. The most resistant plywood is made from hardwood such as maple or birch. These types of plywoods are resistant to water and chemicals. However, they are not very resistant to fire. Hardwood plywood is also generally more expensive than other types of plywood. Other types of plywood are more resistant to water and chemicals but less resistant to fire. These types of plywood are made from softwood such as pine. They are also less expensive than hardwood plywoods. However, they are not as resistant to water or chemicals as hardwood plywoods are. Lastly comes the property fire resistant. Fire resistant plywood is a type of plywood that is designed to resist fire. It is often used in commercial and industrial buildings where fire safety is a concern. Fire-resistant plywood is made with a fire-retardant resin that helps to prevent the spread of fire. Dear students, you can now say that plywood's enduring presence in the world of design and construction speaks to its relevance and adaptability. As technology advances and new materials emerge, plywood continues to hold its own, offering a unique blend of tradition and innovation that makes it a staple in the toolkit of architects, engineers, artists, and craftsmen alike. In conclusion, plywood's journey from humble beginnings to its current status as a cornerstone of modern construction is a testament to its enduring value and versatility. As we look to the future, it is clear that plywood will remain an integral part of our built environment, continuing to shape the world around us in remarkable ways. So, dear students, this was all I had for you in this lecture. Hope you enjoyed the class. See you some other day. Till then, take care and goodbye.